Hey guys, welcome back to my channel. So we're back talking about the sun today because NASA and the Johns Hopkins Applied Physics Lab just released some incredible footage of a probe flying through a solar eruption. I did a video about solar tsunamis a bit ago, but you guys know about those crazy flares that are constantly erupting from the sun. Well, we just drove a probe through a very powerful one, like it's the Fast and the Furious out there. But aside from this flyby being very impressive, it also proved a 20-year-old theory about coronal mass ejections. And this probe is the fastest thing ever invented by human beings. So let's get into it. So first, let's talk about the probe. In 2018, NASA launched the Parker Solar Probe with a mission of making observations of the outer corona of the sun. It was named after Dr. Eugene Parker, a scientist born in 1927 who theorized about the existence of solar wind. And Dr. Parker was actually still alive in 2018 and got to see the launch of the probe named after him.
10, 9, sister star.
8, 7, 6, 5, 4, 3, 2, 1, 0. Liftoff of the mighty Delta IV Heavy rocket with NASA's Parker Solar Probe, a daring mission to shed light on the mysteries of our closest star, the Sun.
And this probe, by the nature of its mission, was going to go closer to the sun than any spacecraft ever had before. According to NASA, it will come within 4 million miles of the sun. And while that may seem far away, it is actually crazy close to fly by a star whose core temperature is 27 million degrees Fahrenheit. Like, that is just unfathomably hot. And on top of that, the sun is so much bigger than the Earth. If the sun were as tall as a typical front door, the Earth would be the size of a nickel. So it's super big, crazy hot, and we sent this 8-foot by 10-foot probe right up to it. The spacecraft systems are protected from the extreme heat and radiation near the sun by a solar shield. This shield is hexagonal, mounted on the sun-facing side of the spacecraft, just over 7 feet in diameter, 4.5 inches thick, and is made of 2 panels of reinforced carbon-carbon composite, which is designed to withstand temperatures outside the spacecraft of about 2,500 degrees Fahrenheit. The shield weighs about 160 pounds and keeps the spacecraft's instruments at about 85 degrees. So basically, in that instrument panel, it's a typical day in Los Angeles. And it has a camera aboard. Actually, 2, and they are called WHISPR, or Wide Field Imager for Solar Probe. And when I was talking about breaking speed records, I am not joking. In 2021, Parker was clocked going 330,000 miles per hour. And by 2025, NASA predicts that Parker will travel at closest approach as fast as 430,000 miles per hour, which is 0.064% the speed of light. Which is not bad, you guys. James Webb, on average, is just doing 720 miles per hour. This is like us getting to the moon in half an hour rather than 3 days, assuming we could survive that speed. Could we survive that speed? Possibly different video. Anyway, it's stupid fast. So since 2018, the Parker Solar Probe has basically been doing its thing. It has had several what they call perihelions, which is our closest point to the sun while in orbit. It's checked out Venus a couple of times, but then last year, on September 5th, 2022, it flew directly through a coronal mass ejection, or CME. According to NOAA, CMEs are large expulsions of plasma and magnetic field from the sun's corona. They can eject billions of tons of coronal material and carry an embedded magnetic field. CMEs travel outward from the sun at speeds ranging from 250 kilometers per second to nearly 3,000 kilometers per second. The fastest Earth-directed CMEs can reach our planet in as little as 15 to 18 hours. And these CMEs matter because they can endanger satellites, disrupt communication and navigation technologies, and even knock out power grids here on Earth. So understanding them and getting data on them is pretty important. And what better data to have than a front row seat flying through one? Look at me, I'm getting all excited. It's just because I want that front row seat. That's what it really is. I'm jealous. I'm jealous of this probe. Here's the footage of the WHISPR camera on Parker. And at about 12 seconds in, it gets pretty crazy. I mean, you can feel that plasma, right? It's just like, boom. It'd be super cool to see that in color, but I get it. Not that kind of camera. Walk before you can run, Marion. I'm just getting greedy now with my NASA footage. So obviously Parker flying through this CME and surviving it, huge accomplishment. And as I said in the beginning of this video, it helped prove a 20-year-old theory. In 2003, two scientists suggested that CMEs can actually push away interplanetary dust, the tiny detritus from planets, asteroids, and comets that is left to drift around the sun. Interplanetary dust is small and difficult to observe, but Parker's WHISPR camera managed to pick out light reflected off the particles. The specks of such light were still very subtle, however, but scientists enhanced the signals by subtracting out the average brightness of images WHISPR had taken during similar orbits. When they did, they found the CME blew dust away along an approximately 6 million mile long path from the sun. Guillermo Stenborg, an astrophysicist from Johns Hopkins Applied Physics Lab, compared the observed effect to a vacuum cleaner, like the sun sort of self-Dysoning. So as far as this CME goes, the theory appears to be confirmed. But obviously more data will be needed, but a paper on this was published by the Astrophysical Journal, and I will put a link to that in the description below if you guys want to take a look. Parker is expected to continue its mission until December 2025, though knowing NASA's track record of extending its missions, who knows how long it could go on. And as of this video's recording, the next perihelion is scheduled for September 27th, 2023. NASA, of course, has a Where is Parker website, but I warn you, it's not as interactive as the Where is Web website. Always sounds weird coming out of my mouth. It's just really an updated picture as to where Parker is, but it does show all the past orbits and all the orbits to come, so I will put a link to that in the description below. I also found in my research this funny little promo that William Shatner did for NASA just before Parker's launch. I will post a video about that over on my Patreon, so if you guys want to see me be puzzled as I try and figure out what this promo is about, come on over to my Patreon and take a look. Maybe you guys can crack it. And I'm sure some of you might be inclined to be less than impressed by eruptions from a star that's 93 million miles away from us, but the sun is the foundation of our solar system. Without its energy and light, there would be no life on Earth. And obviously these CMEs have affected us before, so I think that the further we venture out into space, the more it makes sense to me that we understand these CMEs. I mean, at least the best that we can. To me, it feels more like when we develop a warning system for natural disasters here on Earth. Can we stop tornadoes and hurricanes from happening? No. Is it crazy helpful to understand how and when they will form? You bet. And also this footage is just super cool. It is. Not ashamed to admit it. Footage like this is always my gateway to these topics. Maybe that's sad, but it's true. Please let me know your thoughts in the comments below, and as always, I will see you guys in the next video.